Hanger hanging on a cliff, and that's why they call him Cliffhanger. Actually, I don't know if you guys know who that is, because that might even be too old for you. Which actually, it wasn't like too old for my son, so I figured it might be. Never mind. I don't know. Anyway, yeah, no, I know. I actually got stuck in my head, and that's it. All right. So anyway, I got a question for you. We talked about this thing called mechanical weathering. And mechanical weathering was where you take something and what is basically mechanical weathering? What am I doing when I mechanically weather something? I physically damage it with like Thor's hammer, and I'm just like boom, and I break it apart, right? Yeah, exactly. Rawr, and I break it apart with a hammer or whatever. And I got a question: am I changing? Like, um, let's say I have a rock. You know, what I mean, let's say I have um, I don't know, a a piece of clay, or let's say I have a rock, right? And or quartz. Let's say I have quartz or something like that, and I break it apart. I physically break it apart. Mechanical weathering on it. What do I have now? I have pizza? No, no, that's not right. I have sedimentary. Okay, I have. But what is the sedimentary? Sedimentary, you're talking about like pieces of sand and dirt and dust and that kind of stuff. What is it? Pebbles? What is it made of? If I started off with quartz, it's smaller pieces. Smaller pieces of what? Of rock? What kind of rock? The one you damaged. Yes, exactly. Exactly. Uh, that's what it is. Is if I take something and I physically weather it, I have smaller rocks, baby rocks, smaller pieces of rock, but it's still the same type of rock. Does that make sense? Like, for example, if we have this giant bar of chocolate, we would mechanically weather it with a jackhammer or a sledgehammer or Thor's hammer. Well, I probably wouldn't use Thor's hammer because Thor's hammer has lightning that it deals with, and I don't want to melt no chocolate. So I'd probably use a regular sledgehammer and break it apart. And when I break it apart, it just becomes smaller pieces of chocolate. Does that make sense? All right, now I got a question for you. Say that you guys come into school and Mr. Dalday has sitting on a table a giant bar of chocolate, like that size. Cool. And here's what we do. I've got a giant bar of chocolate, and I want to make everyone hot chocolate because this is really cold. We're talking about like a really, really cold night. What would you do? You'd melt it. I love hot chocolate. Awesomeness. Okay, but what would you do? Would you seriously you would take that and you would just throw it in a big pot of water? Let's say that we had a big pot of water or milk for that matter. Mix it with milk. Yeah, no, but see, I don't think you guys are thinking about this. I would break it. Like, let's say you want your hot chocolate now. What do you do? All right, fine. So let's say I give you a manageable size, something that you can make. Like I give you this much chocolate, which is like a fist size thing of chocolate. What would you do? You would break it up. Why would you break it up? It melts why? Why would it melt faster? That's my question for you. Why does it melt faster if I break it up? It's smaller? Hmm. All right. If I have smaller pieces, then what I would argue is that the surface area increases. And here's what I mean. Like, if my big bar of chocolate was like this, then what's exposed to the heat is just this surface area, right? But if I chop it up into, let's say, I cut each piece in half twice, so that makes it one, two, three, four, five, six, seven, 8 pieces now. What I actually did was I increased the surface area. I doubled it, actually. I doubled the surface area by cutting it in half. And when I cut it into quarter pieces, that means I take my regular block of chocolate and I cut it into 4 pieces like this. 1, 2, 3, 4, 1, 2, 3, 4. I'm actually 4 timesing the surface area. And then if I do it 8, I'm actually 8 timesing the surface area. I'm making more area to be exposed so that the heat can actually heat it up and then melt it. Does that make sense? This is wait. Somebody asked, why is there more surface area? There's more squares, which is why there's more squares because which is why there's more surface area. Jenna, you're a little confused. I'll tell you what. Let me help you out. All right, here, let's do this because I think this will make sense. Let's say we're playing dodgeball, and we got a bunch of the people over here. Got it. And so all of these little heads are students. Okay, we're playing dodgeball, and this is Mr. Dalday's head right here, and I'll be a solid one just because I'm the king. And let's make all the red balls out here. Wait, let's make all the orange balls out here. These are the people throwing the dodgeballs. Got it? So here's what I would do. The people on the orange stuff is going to be throwing at the people in the black. Can you guys hear? Is the audio coming through? It's kind of laggy. I don't know how to fix that per se. The best I can do is log out, log back in. But don't worry, I'm uh, Peyton. You're at MBTA. Peyton, come on upstairs. Like, why are you logging in if you don't? Why don't you just sit next to me? Come upstairs to 312, and I'm in the back room. Um, just ask someone for me. Anyway, all right. You can bring everything up, sure. At least bring your computer. You don't want that stolen. I don't think anyone would steal your stuff, but I'm just saying. All right. So check this out. We're playing dodgeball, and I've got these orange people are people with balls, and the people in the black, that's the people who are dodging, right? And I've got the black, solid dot because I mean I'm the king. Um, so what I would do if I were mean, which I am, is I would make everyone stand around me, right? And then and then you wouldn't be able to hit me with the dodgeball. You would hit all the people on the outside. You know what I mean? But say that you're the people with the dodgeballs. Say you're the people in the orange. What would you do? What would be a smart thing for you to do? If you wanted to hit everybody, what you probably should do is you should probably break it up. Maybe break it up into pairs, you know? I would squat. Yeah. All right. So what you probably would do is I would break it up into smaller pieces. And that way each person can hit. Well, you could hit more people. What's going on, Peyton? Come on in. Um, leave your stuff outside. Go grab that black chair and you can sit down. All right. That's not super laggy now. And you would hit my pretty face. Yeah, and you would put it, but then you'd get hit in the head. Yeah. So, do you guys understand how what I mean? But when I say that if you break it up into smaller pieces, it increases the surface area, or it leaves more people exposed to get hit with a dodgeball. You like dodgeball? By the way, Peyton's here.
Hi.
Now you can see Peyton's pretty face.
Thank you.
So what I'm saying, Peyton, is since you were missing, I have three different scenarios. Okay, this scenario over here is we're playing dodgeball. This is number one. We're playing dodgeball. Got it? And so what I would do, and everyone playing dodgeball are the people throwing, which I'll say are the students,
Okay.
are the people in the orange, and the teachers, which are the black circles, are in the middle. And I'm the teacher with the black, the filled in black one, because I'm just better than everybody else.
Okay.
So what I would do if I were mean is I would make everyone surround me, right?
Yeah.
And then none of the students could hit me with their dodgeballs. Now, if the students were smart, and the students are smart, then what they would do is they would break us apart. They would separate us into smaller groups. And what that does is when you make these smaller groups, it leaves more people exposed to getting hit with a dodgeball.
Yeah.
And that's what I'm saying is um, when you take something and you break it apart, you're giving it more surface area. There's more area exposed to melt, and that's why when you create hot chocolate, um, what you probably wouldn't do is you probably wouldn't take a rock, like a fist-sized piece of chocolate and put inside of a pot and try to melt it. What I would probably do is I'd take that fist-sized thing of chocolate and I'd break it up into small little pieces, and then I would throw that inside my milk. In fact, I would break it up so much that it became a powder. In fact, when you make hot chocolate, don't you guys use powder?
Yeah.
Yeah.
Yeah, we pour the powder inside the
Yeah, and you
water.
pour the powder inside and that kind of stuff. And why would they use powder? Because it has the most amount of surface area that we're talking about here.
Yeah.
So it would melt the quickest, which is good because I want my hot chocolate fast.
Yeah.
So anyway, that's why coffee is grounded into, you know.
Beans, right?
Well, I mean, it starts off as a bean, but it's grounded. So what I'm going to talk to you guys about now is this thing called chemical weathering. All right, wait 1 second. Whoa, what happened? Okay, chemical weathering. Move that up. Chemical. So, mechanical weathering was you took something and you're breaking it up into smaller pieces. Chemical weathering is you're taking something and you're adding some kind of chemical, or it's going through some kind of chemical process. And sure, it might break it up into smaller pieces, but what you're really doing is changing it from one type of something to another. Now that you do the same thing with mechanical weathering is you're changing a big rock into a bunch of little rocks that are the same substance. But a chemical weathering is happening where I'm taking one rock and I'm putting it in some kind of acid or water or whatever, and it changes into another type of substance. Does that make sense? So here's an example, and let me explain to you what's going on with chemical weathering. Surface process. There we go. Great. All right. So chemical weathering is really important, and um, it's where do we get soil? Soil is essentially just straight up different from rock, right? Soil isn't sand. Soil is something different.
It's like dirt.
Soil and dirt, those that's different from rock. It's not dirt is not rock. It's it's something different because if I were to take a rock and I would just pound it into submission, I would end up with sand. I wouldn't end up with dirt. I would end up with sand. But dirt and soil, that's something different. And I'll tell you what happens. Okay? Now, do you remember how I said, here's my rocks? And I've got myself igneous rocks, right? Remember what those are? What are igneous rocks? They're created where?
Underneath the crust.
In right from lava, magma, they're melted out. I've got sedimentary rock. How are those created?
I don't know how those are.
Well, they're going to tell us. Um, how is sedimentary rock created? It's a bunch of different materials like sand and stuff like that, and you just squeeze it, right? And then I've got metamorphic rock. How's metamorphic rock created? By the way, if you do the Crayon Rock Lab, this almost becomes really odd, or it helps you remember it very well. Um, the metamorphic rock comes from heat and pressure. You take a sedimentary rock and you apply like super heat to it and apply super pressure to it and it turns into a metamorphic rock. And I can change all of this stuff back to a sedimentary rock by simply breaking them apart. Boom, it becomes sediment, and then I can turn that into sedimentary rock. If I wanted to turn it to igneous rock, I would take any of these rocks, I would melt it, and then that lava would form, that magma would form into a rock, and that would be an igneous rock. So I can turn this rock into that rock, or this rock into that rock. I can turn all of this into this rock. And then how would I turn the igneous rock or the sedimentary rock into metamorphic? I would apply superheat and super pressure. Does that make sense?
Super pressure.
Yes. All right, good. Now, in those rocks, we find this right here. You find these in all types of rocks. This is found, these right here are called minerals. Your minerals include feldspar, quartz, rose quartz, um, malachite. They're really pretty. See? Can you guys see the mineral? Yeah, I like gold. Gold's a good one. All right. So what happens is, let me give you this example. When we have the Earth right over here, right? These minerals that are created inside of this rock. So we got a rock right here that's created inside the Earth, and it's got a bunch of different minerals inside of it. And depending on what type of minerals we find in it, we can kind of say what type of rock it is and all that kind of stuff. But it's got a bunch of different minerals inside of it. Now, when you're talking about deep down into Earth, these minerals are very stable. But when you when these rocks are pushed up to the surface of the Earth, on the surface of the Earth, minerals are very unstable, right? And what happens is when you have something when it was created, it was stable, but when you bring it to the top, it becomes unstable. What's going to happen to that rock? They're going to break apart. It breaks and it transforms. And that's a part of chemical weathering. Or it's like a chemical reaction. The minerals inside of the rocks will react with the air, and that will cause the reaction to take place, and then boom, this thing turns into a different type of rock. Does that make sense? All right, here, let's try this one. What do we got here? What is this? What is that a model of? Water molecules. How do you know it's a water molecule?
HOH, H2O.
H, two H's.
Oil.
Oh, so it's H2O. H2O, also known as water.
Water.
I like water. Water's good. Um, Water's a pretty awesome molecule, and it can do a lot of things like dissolve things, right? It can dissolve rock, and when it dissolves rock, it actually changes it into a different type of rock. So some rocks can dissolve in water, and some minerals will change if you add water to their substance, and that changes the rock chemically. Does that make sense? So that's one way of chemically changing this rock. All right, another way is this. Check this out. This is actually pretty cool. Look at just this picture right here. We got one statue and another statue.
What's up with that face?
What's up with which face?
That face. Look at her face.
Which one? This one over here?
Yes, that one.
It's right here. Here's her face. It's right there.
It's like gone. How do you do this?
Okay. This is the same statue. This is the same statue. Her face is gone. Her features didn't just wear away. This was taken in like 1960, and this was taken in about 2000.
All that hard work went into this.
Yeah, the hard work went into that marble statue. What's going on? What happened?
It's marble? What's even going on?
Actually, I think it was marble. Yeah. Anyway, water weathered it? No, no. Actually, what happened was acid was poured on top of her.
Like acid rain?
Exactly, it's acid rain. What happens is yeah, I know. Who would pour acid on a statue? No, what happens is you got a lot of factories, and the factories release sulfur dioxide, nitrogen gases, or nitrogen oxide, and those kinds of gases into the atmosphere. Those acidity gases, acid gases. And that stuff comes down in the form of rain, and they give you acid rain. And because this statue was outside and it was getting rained on, the acid actually burned away all of the features.
That sucks. That's all that hard work.
So this statue, which is the same statue, is actually caused by acid rain, which is caused by the pollutants in the air. Now, it's actually, you would say, wait a second, but it's still the same stuff. So isn't that physical weathering? And my answer is this. No. The stuff I mean, yes, the stuff that's left is still, whatever it started off as, but the stuff that got melted away, that is a different type. That is a different, substance altogether. So this is actually a example of chemical weathering. Cool?
Cool.
All right.
Cool.
What happened here? That looks like a lion to me. That looks like a dog or a cat or something like that.
Is that a horse in the background? Is that a rock?
There's a rock in the
Oh, I
background.
thought it was a horse.
All right. So we got our dog rock. Our dog rock. What color is it?
Wait, the one on the left?
No, the one I circled.
Oh, that's like,
It's reddish brown.
yeah.
And this is a rock. This right here is a rock. What's going on with that?
Oil.
Oil?
It's oil.
Looks
Because
kind of like
it
oil.
looks like a rainbow when there's oil on the black.
Red,
top.
muddyish brown.
No, it's like a rainbow. It's
Ah,
colorful.
Sophia's got it. It's not oil.
It isn't
But Sophia's got it.
rust.
It's rust.
Rust.
It's because
Rust.
there's what rusts?
Like steel, iron.
Iron rust, right? Metal rust, iron rust. And so what do you have when you when you have iron inside of your rock?
There's metal in it.
Well, it
And
will
there's-
chemically react with the air or the oxygen, and that will oxidize it and cause it to rust. Does that make sense?
But that was water that when you pour water on it, on the butt, it'll rust.
So, now I want you guys to be careful with the lingo here. When we're talking about weathering, that's when we're actually talking about breaking things down. Got it? But when I'm talking about erosion, erosion is something different. Erosion, what I've been showing you here is not erosion. This is not erosion. None of this stuff is erosion. This is weathering, and weathering comes in two different flavors. One is mechanical, which means I'm taking something and I'm breaking it apart into little pieces, which are still the same type of material, just smaller versions. And the one is chemical, where I'm taking something and I'm reacting with it chemically, and it changes that substance into something else. Cool? All right. Now, this boy isn't going to die, and the reason why is because this is one solid piece of rock.
It is? It
Yes.
looks all broken up.
It's not a rock that is placed on top of another rock. It is a solid piece of rock that is actually connected all the way through, even though you might not be able to tell. And maybe that might be a bad picture. But what's going on here?
Standing underneath a rock.
He's standing underneath a rock. All right. What's going on here is I think that this rock used to be a big boulder, right? And what happens was I think that the inside of it was an igneous rock.
Over here is more igneous.
And over here is softer rock. So as the wind will weather this thing down, the softer rock will break away. The igneous, stronger rock will stay solid. And that's why you create these weird rock formations.
Like,
Because it's two different types of material. Like here, this one's pretty cool. This one's called Devil's Tower. It's in Wyoming.
I saw that in the Close Encounters of the Third
Yeah, exactly. This is the one where they went to the top of this thing and it was like doo doo
Yeah,
doo doo.
with the alien stuff.
Right, right, exactly. That's Devil's Tower. It's in Wyoming. It's kind of I think it's like designated as one of the um like natural world wonders or whatever. Here's what it is. It's a solid piece of rock. It used to be inside of a volcano.
That's cool.
Volcano was like this. But I think the center of that volcano kind of, well, it didn't collapse. It actually uh there was what you call it, um, magma inside, and then that magma turned into what?
Stone.
Stone. What kind of stone is turned in? What kind of rock is igneous rock?
Dang it, I was
It gets turned into igneous rock. Igneous rock is super tough, right?
super dumb.
So all of this mountainside wore away through weathering, and it left you with this weird structure that was on the inside because that's what's left over because the igneous rock is super tough. Does that make sense?
Yep.
All right. Now, let me warn you, and actually, you know what? We're done. So I'm not going to end my class with a cliffhanger hanging on a cliff. And that's why they call it cliffhanger. Anyway, um, I'm actually done, but let me warn you with the lingo because a lot of you folks are saying, "Oh, it erodes. It's eroding. That's what's going on." No, the process of taking something and breaking it down is not erosion. The process of taking something and breaking it down is what is it?
Wait.
Weathering. There we go. Weathering. Now, what is erosion then? Okay. All right, Sarah. I love Minecraft. Okay, fine.
I
Sarah,
like how to
Sarah makes a
person, a blockhead. I don't know how to do a Minecraft person.
Don't worry, I don't know how to either. So, you know.
alright. She makes a giant
Statue of herself out of many, many pieces of blocks. And what? You got to choose what type of block you use.
Yeah.
Do they have gold blocks?
Yeah, there's gold.
Okay.
Diamond,
So
silver.
Sarah makes
A um Sarah makes a thing out of, let's make it silver. Gold is too expensive. All right.
No, it's actually worthless.
And this is her statue. She made it of herself. It's giant. It's a giant statue. Here she is, her little Minecraft person, and it's pure silver.
Pure.
Let's make it. Let's make it iron or something like that. It's an iron giant statue. Got it?
Iron giant.
Okay. Here's what weathering is. Weathering is if I come through and I break apart your thing. And so now Sarah has
Do some Minecraft folklore. Oh, that sounds good.
a bunch of smaller blocks. Just a big stack of them now. What type of weathering was that?
Breaking block. Oh, wait, that was.
Mechanical weathering. Because I took the same stuff and I broke it apart into smaller pieces. But what if I didn't break Sarah's Minecraft statue down? What if I put it inside of a super oxygenated environment?
Super oxygen.
Well, then what's going to happen is Sarah's Minecraft thing kind of do this. What happened there?
It's bleeding? No.
It's not bleeding.
it's an iron giant. How is it bleeding?
There was red on it. I thought it was.
It's rusting. Exactly. Your iron giant is rusting, Sarah. And what type of weathering is that?
Mechanical? No, that's
That is a chemical change. I am chemically changing this iron into rust, which is a different substance altogether.
Yes.
All right. Now, so me breaking this down in two different ways, turning it into small pieces of iron or turning it into rust, that is weathering. When I talk about erosion, which is what we're going to get into next quarter, actually, because I'm gonna put a pause on all of the stuff I'm teaching you, and next week I'm going to start teaching you ACT stuff. But when I talk about erosion, what erosion is all it is I'm moving. What's going to happen to this big pile of stuff?
It's gonna like sink.
Eventually.
Yeah. What does it do? Your dad's okay.
All right. What's going to happen, like if I just leave this big, these small chunks of stuff, they're going to blow away. They're gonna fly away. Yes, exactly. They're gonna fly away. They're gonna blow away. Maybe a rain might come and it will wash everything away. And so now Sarah will be left with maybe some blocks over here,
Dirt blocks.
then a few blocks over here. Over here. That is what is erosion. Erosion is after you take something and you weather it, you break it down into small pieces. You take those small pieces and through wind or through rivers or through rain and all that kind of stuff, it takes your small pieces that were broken apart and moves it from one spot to another. And that movement is what we call erosion. So when you see something and you say, hey, something was eroded, that's actually not necessarily true. You have to say something was weathered and then it was eroded. It was the process of breaking it down into smaller pieces is called weathering. The process of moving something from one spot to another, or those small pieces that you broke down from one spot to another, is called erosion. Are we cool with that? Do you guys understand that lingo?
Understand the lingo.
All right, then we are done, and I am done on time.
You're not done.
Yeah.
Let's keep it going.
No, I'm done. I'm done. No cliffhanger for today.